So dear friends, this is Hemant Pradhan. Again, welcome you to this YouTube platform, that is e-learning hub YouTube channel. And in this lecture today we shall be learning about the different types of mathematical functions that are very much essential while talking about the mathematical operation in economics. Okay, so there are actually different types of functions. We have already talked about the on the basis of your set theory and on the basis of your what real number theory. But right now we are going to talk about the other mathematical functions which are also important in this context. Clear? So there are actually other important function. What is your linear function, quadratic function, exponential function, logarithmic function, and logistic function? So let's discuss one by one clearly. Clear? So what is the first meaning of your linear function? What is the first meaning of your linear function? Can you tell me? A function of the form fx where ax plus b, and a and b are the constant is called a linear function. Okay, the graph of this linear function should be a straight line. What will be the shape of the this graph of this your linear function? It should be a straight line. Okay, on the xy plane we can say. Here a is the what slope of the straight line. Whenever we are talking about the a, that is the slope of the function, and b, that is the intercept of the function, and on the y axis actually. Clear? So whenever we are writing the equation y is equal to ax plus b, then that b that represent your intercept, and then a this represent your what slope. Okay, so and whenever we are representing that there are in what x and y graph. Okay, we are taking in the graph x and y axis, and the intercept will start from the y axis. Clear? So that is the thing, and it should be a straight line. Okay, and if b is equal to 0, the graph is a straight line passing through the origin. So if the b is 0, then what will happen? The graph is passing through the what origin. Okay, the graph will passing through the origin when your b is equal to 0, because there is no intercept. If it means that there is no intercept or metal. Clear? So like the graph is a straight line passing through the origin, we can say, when the b is equal to 0. Clear? But if a is equal to 0, the graph is a straight line parallel to the x-axis. But whenever we are talking about, we are writing a denotation or slope equal to 0, it means ax plus b. We have written the ax plus b. Okay, and in that ax plus b, what if the slope? What is the slope? A. And if a is equal to 0, then what will happen? Then what will happen? The straight line will be parallel to the x-axis. Clear? So here if you take the x-axis and y-axis, then what will happen? Then it should be a parallel to the x-axis. Clear? So this is the thing you should know about the linear function, and this is very much important in case of your mathematical operation. Clear? And here the distance b unit from the x-axis. So whatever the parallel line that will appear, so distance is what? The b unit, whatever your intercept term. Clear? Okay, it means, for example, whenever you are writing that, whenever you are denoting in a diagram, okay, then x-axis and y-axis will draw a what? First parallel line. Clear? And whatever that parallel line, that is nothing but the b. Okay, and here slope equal to 0 we can say, or a equal to 0. Clear? So let's come to what? The different types of expression of your what? Linear function. Clear? And here the linear function must be a what? What we can say? Exponent of the what? Variable must be 1 actually. Clear? Then only it will be a linear function. Okay, I have already talked about what is the linear function, what is the quadratic function, what is the cubic function. Okay, in the different types of polynomial function we have already talked about that. So here the linear function means what? The exponent, the highest power of the variable is 1. Then only it is called your linear function. Okay, So clear?
Yes.
So let's come to the what? Different types of a different notation of your what? Linear function. Clear?
Yes, sir.
So first notation is what? We can write down that y is equal to, as I have written, mx we can say plus c. Okay?
Yes.
Mx plus c we can write down first. Then second is we can write down that x divided by a plus y divided by b, which is equal to 1 we can say. Clear? Here a and b are the intercept term made
Sir.
on the x axis and y axis. Whenever we are writing in this case, the a and b are the intercept made on the x axis and y axis, and a are the intercept on the x axis. Clear?
Yes, sir.
But we are talking about the intercept on the y axis, that is your what? B. So term B, that is the intercept of the y axis.
Y axis. Yes.
Okay. So next come to the what? Third number point, that is y minus y1, which is equal to m x minus x1. This is a straight line passing through the point x1 y1 and having the slope m. Okay. So this also be represents a straight line, and this straight line passing through the point x1 and y1. Clear? And having the slope, and what will be the slope of this curve? The slope is m. Clear?
Yes. Yes.
And another linear function we can say y minus y1 divided by x minus x1, which is equal to y1 minus y2 divided by x1 minus x2. Clear? In this equation, the straight line, it is also be a straight line. Clear? All the linear functions should be a straight line, and that passing through the point x1 and y1 and y2 and x2 and y2. Okay? It means it will pass us through the 2 points. That is your x1 y1 and also x2 y2. Clear?
Yes.
So all these are the some notation of your what? Linear function. Understood? So let's let's discuss the next function, that is your what? Quadratic function. Clear?
Yes. Yes.
So a function of the form fx, where a x square plus bx plus c, where a, b, c are constant, is called a what? Quadratic function of a polynomial of degree 2. So when there is the highest power of the variable or the exponent, that is we can say x, that is if 2, so we can say it is a quadratic function. Clear?
Yes, sir.
And whenever we are talking, I have already told you in case of your what? Polynomial function, that if the highest degree of the function is what? The highest power of the function is 2, then we can say it is a quadratic function.
Quadratic.
Okay?
Yes.
And here this notation is also written as. Clear? A quadratic polynomial can be expressed as the product of the two linear factors. It can be expressed as the product of the two linear factors. Okay?
Yes.
And what are the properties of your, there are some properties of your quadratic functions as stated below. So there are some properties which has been discussed in the okay, below.
Yes.
So that you can see. So the functional form, what is the functional form? We can say ax square plus bx plus c. Okay, because here we can see the exponent 2 is the highest power here. Okay.
Yes.
Next, and in this way we can write down that here a, we can take the a outside. Okay. Then we can write down a square plus bx divided by a plus c divided by a. Okay.
Yes.
Then we can also write down that in this way it is a outside a we can take, and here x plus b divided by 2a to the power square we can take, plus c divided by a minus b square divided by 4a square. If you solve this, then we can able to get all these things. Clear?
Yes.
So next come to the what? So here you have to notice that we will get and we will arrive at this point. Okay.
Sir.
If you derive and if you solve in this manner, then we will get this point a x under bracket x plus b divided by 2a to the power 2 we can say, plus 4ac minus b square divided by 4a. Okay.
Sir.
So here if a is a positive number, then fx takes its minimum value at x equal to x minus b divided by 2a. Clear?
Sir.
Here if the value of the a is a positive number, okay, then
Sir.
the function fx that should be a minimum value. And what should be that minimum value? At x equal to minus b divided by 2a. Okay, if you
Yeah.
take the minus b divided by 2a equal to x, then we should get a minimum value of this function if a is positive. Clear?
Sir.
But if a is negative,
Negative.
then we can have a what? Maximum value of the
Maximum
function
value of x
at x equal to minus b divided by
by 2.
2a. If that a particular a is a what? Negative value, then we can have a maximum value of the function. Clear?
Okay.
The graph of the function or the quadratic function called a parabola. So the graph of a linear function is called your straight line. Like that,
Yes.
in this case, the graph of a quadratic function, that is called your what? Parabola. Okay.
Yes.
The point at which the minimum or the maximum value occurs is called a vertex of parabola. So whenever we are deriving or whenever we are writing the what or making the graph of this quadratic function, we can have the minimum value and the maximum value. Okay. So
Yes.
that minimum value and maximum value are called your what? Vertex of the parabola. Clear?
Sir.
So this is all about your what? Some features about your quadratic function. So let's discuss the graph. Okay, you can see
Sir.
below that the graph of fx where x is a positive and we can a is a positive and a is a negative term. Clear? And
Yes.
when a is a positive term, the graph should be like this. You can see. Okay, but
Sir.
when a is negative, actually here actually this is given a is positive in the right side of the diagram. That should be actually a is negative.
Negative.
Clear?
Yes.
So the graph should be like this U shape. Whenever we are taking the positive value of a, then the graph should be U shape. Okay, and that
Yes.
denote the minimum point. But
Minimum.
if a is negative, then we can have the maximum value of the function. So the graph should be inverted U. Okay, and
Yes.
that when it started to this what the tangent, that
Maximum.
is called what? Maximum value. Clear? So the graph of the parabola should be like this. Okay.
Yes.
So next come to the what? So whenever we are going to find out the minimum value and the maximum value of a function, okay.
Yes.
So they are the following steps that has to be taken up. So what are that following step? The first step is find the values of a, b, and c. Okay.
Sir.
Next step is your what? Determine the values of a is positive or negative. Okay.
Yes, sir.
And if a is positive, then the point occurs at the what? X equal to minus b divided by 2a. That should be a minimum point.
Minimum point.
Okay. Substituting
Sir.
this value of x in the function of x, we can obtain the minimum value of this function. Clear? But
Yes.
when we are getting a value that is a negative value of a, then we have a maximum point occur at the point at the what? X equal to minus b divided by 2a, and substituting this value of x equal to minus b divided by 2a, we shall have what? The function value which has the maximum value of the function. Clear? So
Yes.
these are the steps while deriving or while making the notation of this in a graph form. Okay.
Yes.
So let's discuss and roots of the quadratic equation. Here it is given that the roots of the how we are going to derive the roots of the quadratic equation. Okay, so this is very much important. Actually, you should know how can you get the roots. Roots mean we are deriving the two values of the quadratic equation. Okay, and that is called what? Roots of the quadratic equation. Okay,
Yes. Yes.
so let's see what are the different values that we are going to get. So we can say the expression of this quadratic equation from a x square plus bx plus c. Okay,
Yes.
here we can take the a common and we can write down like this: x plus b divided by 2a whole square minus b square minus 2ac divided by 4a. Okay, then
Yes.
the roots of ax square plus bx plus c is equal to 0. We can denote like we have to take it is equal to 0, then only we can get the values of this function. Clear? Are
Yes.
given by, we can also write down whatever we have written in the right hand side, that equal to 0. Okay, let's take that
Yes.
equal to 0. Then you derive the value, then you derive the value. If you solve this, then we can able to derive. So at this point, so here we can able to get the x equal to minus b divided by 2a plus minus under root, we can say
B square.
b square minus 4ac divided by 4a square. Okay, in this notation we can able to get. So here minus b plus minus b square divided by 4ac under root divided by 2a will get. Here the roots are, what are the roots? Minus b plus under root b square minus 4ac divided by 2a and minus b minus under root b square minus 4ac divided by 2a. Okay,
Yes.
so if you exactly cannot get the value of the two variable, we can say x or y. Okay, then in this way we have to take. And what is the formula for this? And whenever we are dealing with the quadratic equation, we have to solve this. In our metric classes we have already discussed how to solve this. Okay,
Yes.
so this is actually formula that you have to remember. Minus b plus minus what? B square minus 4ac under root divided by 2a. And where we are getting the two value, one if you take the minus b plus, and another we are taking the minus b minus. Okay, so
Yes.
in this way we can get the two values. So remember here, if b square minus 4ac is greater than 0, the roots are real. Okay,
Yes.
and if b square minus 4ac is equal to 0, the roots are real and equal. But third
Yes.
point is that if b square is b square minus 4ac is less than 0, the roots are imaginary. Okay,
Yes. Yes.
so what is the meaning of real and here imaginary? We can have the real root
Real number.
or real number, we can say. Clear? And
Yes.
if the b square minus 4ac is equal to 0, the roots are real and equal, both the values are same. But when b square minus 4ac is negative, then the roots are imaginary. We cannot actually exactly predict what should be the value. Clear?
Yes.
So this is actually your about your
Roots of quadratic.
roots of the quadratic equation. Clear?
Yes.
So let's discuss next your exponential function. A function having a variable base and a constant exponent is called a power function. So what called a power function? A power function, if we can say having a variable base, the base is a variable and exponent is constant. If the exponent is constant and base is variable, then we can have the, it is called what? Power function. And we can write down that is equal to y is equal to x to the power 3. Here 3 is the exponent. Okay,
Yes.
and x is the what? Base, and base is the variable. It means we can take any value of the x, but we cannot change the value of the exponent, that is constant. So such type of function is called what? Power function. Clear?
Yes.
Okay, then any polynomial in x is a power function. So whatever the polynomial we are getting, that is called what? Power function. A function having a constant base and a variable exponent is called an exponential function. It means what is the meaning of your exponential function? When the base is constant and
Yes.
the exponent is variable, we can say it is a power function. Clear?
Yes. Yes.
If you write down that the base is a constant, means a y is equal to a to the power x. Here a is the base, okay, and that is constant, and x is the exponent, that is variable. Okay,
Yes. Yes.
then such type of notation is called what? Exponential function. Clear?
Okay.
And there are some expression of exponential function is given: a to the power x, a to the power into a to the power y, which is equal to
It or x plus y.
a to the power x plus y.
Yes.
Clear?
Yes.
And we can say the 2, that is a to the power x divided by a to the power y is equal to a to the power x minus
X
y.
minus y.
And point number 3, a to the power x into y, this is equal to a to the power xy. Clear?
Yes.
And these are the some notation you have to see. Clear? All these are the
Yes.
exponential function. Okay, here you
Okay.
have to notice that the base should be constant and the your exponent is variable. But in case of your power function, it is reverse will happen. The variable is base and constant is the exponent. Okay,
Yes.
clear?
Yes.
But the simplest exponential function is, so what is the simplest exponential function? We can say y is equal to a to the power x, where
X.
a is positive. Okay,
Yes.
and not equal to 1, and a is not equal to 1 also. Clear?
Yes.
And the exponent x is any real number. And what is that exponent? That exponent can be any real number. Okay,
Yes.
the function fx, where we can say is equal to a to the power x, is called an exponential function to the base a. It is called what? Exponential function of to the base a, we can say. Okay, for example, y is equal to 2 to the power x. Here the base is 2. And
Yes.
we can also write down y is equal to 3 to the power x. Here the base is 3. Okay, and
Yes.
also we can write down the exponential function is equal to y is equal to 1 by 2 to the power x. Here 1 by 2 is the base. Okay, and that are
Yes.
constant. Clear?
Okay.
And you can see the graph of different exponential function. Okay, so first one is exponential function when a is equal to y, when y is equal to a to the power x, where a is positive, a is sorry greater than 1. Okay,
Yes.
if the value of a is greater than 1, then we can have a curve like this. It will upward sloping and it will intersect through the what? Your
0,
vertical
1,
axis.
1.
Okay, 0 1, whenever we are taking the x equal to 0. Okay, and if a is greater than 1, then we have a positive slope curve. Okay,
Okay.
the exponential function when y is equal to a to the power x and a is less than 1, then in this case what we are getting? We are getting a what? Negative slope curve, where we can say the x equal to 0 and y equal to what? 1. Okay,
Yes.
in this way we are getting a negative slope curve. So here remember, if the base is greater than 1, then it is a positive slope, and if base is less than 1, then it is a negative slope curve.
Negative.
Clear?
Okay.
But the logarithmic function when y is equal to a to the power x and a is greater than 1, and y is equal to 10 log a x, or a is greater than 1, we can have a curve like this. Okay, so here the a to the power x, when a is greater than 1, it should be positive slope. Okay,
Yes.
then in the another graph we can denote that logarithm function in the expression like that, the log x, which is where a is greater than 1. Okay, so it should be a positive function, but in a separate what is quadrant, we can say. Clear? We shall discuss what is the logarithm function. We can actually express the logarithm function into a exponential function and exponential function into a logarithm function. The
Logarithm.
conversion of both can be possible. Okay,
Yes. Okay.
so you have to notice that here always the exponential function that are going through the point 0 1 0 1, but here it is actually there is a mistake. In case of a logarithm function, it should be 1 0, and whatever the logarithm function, that must be passes through the 1 0 point. Okay,
Okay.
so let's discuss. Actually the most used exponential function is y is equal to e to the power x. So this functional form is very much used in your exponential form. Clear?
Yes.
This function is very much essential and very much used, and where e is the irrational number. So what does that e denotes? The e denotes the irrational number. Okay, which values?
Natural exponential.
Yes, it is called what? Irrational number actually. Clear?
Yes.
And
Okay.
which values lies between 2 and 718. Approximate value is of E is equal to 2.718. Okay,
Yes.
and approximately we can say also it is 2 also we can sometime take. Clear? The precise definition of the base E and its advantages can be find out in the logarithm function. So what is the precise definition of base E and the advantages can be find out in the logarithm function, and what are the advantages of E that can be find out in the logarithm function we shall discuss. Okay, so what is the meaning of logarithm function? So what is the meaning of logarithm function? The logarithm of a positive number y to base a, where a is equal to 1, is the exponent to which the base is raised is equal to the number. So here we have to say that here the positive number y to the base a, and where a is not equal to 1, the exponent is the exponent to which the base is raised to equal the number. It means that if y is equal to a to the power x, if y is equal to a to the power x, then we can say in the logarithm form, then log a is the base y which is equal to x. Clear?
Okay.
So here whatever the x, whatever your what the base in your first equation, that is a, that will return in a logarithm function, and log base a we can say y, that is your functional value, and equal to x we can denote. So such type of expression is called what? Logarithm. It means wherever you are getting the log, okay, that are your what? Logarithm function. Clear? So how we can actually transform this function into a logarithm function? Y is equal to a to the power x, okay, that a is the base and x is the what? Exponent. So in the logarithm function we can write down log base a y is equal to x. Clear? So this is the from your exponential function to logarithm function. Clear? So if y is an exponential function, x is logarithm function. So if y is a what? Exponential function, okay, it means of the type this, where base is a constant and exponent is your what? Variable, then only we can able to interpret in a logarithm function. And x is a what? The x, it means it inverse of the exponential function. X equal to we can say log a y, that is your what? That x is your what? Logarithm function. Clear? Yes. But y, whenever we are denoting the y a to the power x, then this y is your what? Exponential function. Clear? Okay. So it means in a reverse manner we can represent the exponential function into logarithm function and logarithm function into exponential function. Clear? Okay. The exponential function and the logarithm function are inverse function. So here it is clearly mentioned it is a inverse function to each other. Okay. The logarithm functions have the following properties. So what are the properties of logarithm function? The first property is log base a xy is equal to log x plus log y. So you are considering the base a actually. Clear? Okay. So whenever you are writing the log base a x into y, okay, then we can have log base a x plus log base a y. Okay. Next property is your what? Second, that is log, if that there is a log base a and x and y, that is the two variable actually divided, then we can say log x minus base a minus log base a y. Clear? Okay. In this way the third property is log a x to the power n, log base a x to the power n, then it can be represented in a n log base a x. Clear? Okay. Next come to the what? Log base a x, this is equal to we can say log base b x, okay, into log a base b. Okay. In this also we can it is represented. Clear? Next come to the what? Point number fourth. Log base a x is equal to log base b x into log a b. Okay. Actually,
Log x with a base
a base
equal
and
to log x with base b
yes,
into log b with base a.
yes, we can
Okay.
take it like that. Clear? Understood or not?
Okay. Yes, sir.
So here log x with base a, which is equal to log x of base b and log a
Log b.
log b and base a. Clear?
Okay.
So the graph of this equal to y is equal to, we can say, log base a x, log x base a. Okay, where a is positive, entirely lies in the first two quadrants. So all these graphs entirely lies on the what? First two quadrants. Okay,
Okay.
so whenever we are plotting the graph, that should lie on the first two quadrants. Okay,
Okay.
so let's see. Hmm. So let's come to the what? Your logistic function. The general equation of the logistic function is given like this. So this is your general equation for the logistic function. You can see the your page that function of x is equal to c divided by 1 plus a into e to the power minus rx. Clear?
Oh, okay.
Where c, a, r, all these are the positive constant. Okay,
Okay.
and the graph of this logistic function look like a stretch S shaped. It means it look like a what? Stretch S shaped. Okay,
Okay.
and are increasing or decreasing between the two horizontal lines. And what will happen? The graph of this is increasing. Okay, or it is
Okay.
decreasing in between your what? Two straight line or two straight, we can see. Within that two horizontal line, the graph will increasing or decreasing. We have the what? One curvature. Clear?
Yes.
One change in between that curve. That's why it is a stretch S shaped curve like. Clear?
Okay.
So for small values of the independent variable, the increasing logistic function behaves very much likely an increasing exponential function. If the values of the independent variable is small, clear? Then the
Okay.
increasing logistic function that behaves like what? Increasing exponential function. Like your increasing exponential function that we have talked about, how we are getting the increasing exponential function? A to the power x, where a is greater than 1. Clear?
Okay. Yes.
So in this case, if the value of the x is small or very small, okay, independent variable that is small, then we can have a similar like the what? Your exponential function, the increasing exponential function. Clear?
Okay.
But however, for a large value of the independent variable, if the value of x is large, then which type of we are getting? The two functions behave quite differently. Okay,
Okay.
the graph of these two functions will be represented in a different manner. So let's see what is the graph of your logistic function. Okay,
Okay.
you can see in the page that 4.20 the graph is, it is a increasing or decreasing graph. Okay, on the x-axis
Sure.
we have taken the point of maximum growth, and in the y-axis we have taken the value of y. Okay, and where
Yes.
the maximum growth rate that can be possible, y is equal to c here. Okay, beyond that
Okay.
it is not possible. Actually y is equal to c, and within that actually horizontal line y is equal to c to the x-axis, in between that the graph is increasing or decreasing. Okay,
Okay.
so this point is called your what? Curvature point. And below that point it is a decreasing growth rate, we can say, or above that point we can say it is a increasing growth rate. Okay, so that's
Okay.
why it is a what? Stretch S shaped curve. And in between that, in between your y is equal to c and the horizontal axis, the curve will lie. Clear?
Okay.
And these are very much essential whenever you are utilizing in our real life quantities or real life example. Clear? Because which
Yes.
growth rate level of, because the rate of growth changes from an increasing growth rate to the decreasing growth rate. Because
Yeah.
increasing decreasing, whenever you are fluctuating our GDP, and we are whenever you are talking about the other thing also, our quantity is fluctuating. Okay, so
Yes.
when that quantity is fluctuating or increasing or decreasing, such type of curve can be represented in a logistic growth function. Clear?
Okay. Okay.
So this much for today. Thank you. Actually, I hope you people are little bit understood what is the actually different types of function. We shall actually discuss it separately in a two classes. What is the meaning of your exponential function and what are the operation of exponential function and the logarithm function? Clearly, these two functions are very much important. For the time being, you must know different types of function. In our next class, we shall discuss about clearly what is your exponential function and what should be the graph of your exponential function and the different operation of your exponential function and logarithm function. Clear? So for the
Okay.
time being, you must know all this concept. Okay.
Yes.
So thank you.